Good morning. We are actually going to skip a lesson in our notes, so you'll have to jump over a few pages. Our primary reason for skipping is because most of that graphing we need to do in the graphing calculator, and I realize that you all do not have those at home. So we're going to skip that for right now. Now, we are going to utilize Desmos. I'm not sure how familiar you are with that, just for what little graphing we're going to need to do today. So I will walk you through that. So you need to find this page in your notes. This is lesson 4 on roots and zeros of a polynomial and multiplicity. So the point where the function intersects the x-axis is known as your zero. We know that. Sometimes it's also called roots. Zeros or roots are where your function intersects the x-axis. And so a polynomial function of degree n can have at most n roots. And so remember, what we mean by degree is the exponent. So the biggest exponent that you have is going to dictate the number of roots or zeros or answers, if you will. Okay? So an even degree polynomial has an even number of roots or zeros, or potentially it could have no zeros. And then an odd degree polynomial is going to have an odd number of zeros. So for example, in this function, we know that it's going to have 3 zeros because of this x to the third. So I want you to go with me now to Desmos. I don't know if you're able to pull this up in a second tab while you're listening to me. But if you go to desmos.com, it should look like this. And you can click to open the graphing calculator. And you're able to just type. So I want you to type in that function there. X to the third. Okay, I just use that x and then the AB there to the third. And then plus x squared. And then minus 2x. I've never used this before either, so it's a learning process for all of us. So that is that function. If you graphed it in your graphing calculator, or we can see here, that's what that function looks like. And if we look at the zeros, it has 3 zeros right here, 3 places that it crosses the line. So in that blank on your space, on your page, you'll just write those in. -2, 0, 0, 0, and 1, 0. Oh no, I've lost my paper. Okay. -2, 0, 0, 0, and 1, 0. Okay, so our zeros then, we could say x equals -2, 1, and 0. And we could graph that function. You might need to look back at it just a minute to be able to graph it. But there were our zeros. And I think it went up to about here. So something like that is how we would graph that function. It's not perfect, but it's good enough. So we can go ahead and try that second one. Put that in your Desmos. So we have -x to the fourth. Plus 5x squared. Minus 4. And that's what that graph looks like. So you can see there we have 4 zeros. So you can write those in on your page, and then we can graph that. Notice that it goes up to 1, and there's that point that it goes up to. -1.5, 2, and 2 1/4 is about where that goes. So we can graph that on our page. So again, our zeros are at -2, 0, -1, 0, 1, 0, and 2, 0. And we can graph them. I think it'll drop down hardly enough there. Again, not perfect, but decent. That's somewhat what that graph looks like. Okay? So that is how we can find zeros by graphing, and it's pretty easy it's a little easier actually in Desmos than on your graphing calculator, but I will show you how to do it when we do some more graphing stuff on your calculator when we are back in school. So let's look at linear factors. We can also factor equations to find the zeros. So let's take, for example, here is our equation. If you look there, the first thing that stands out to me is you can factor out an x. And so that leaves you with x times x squared minus 2x minus 15. And then that can be simplified, not 15, yeah, that's right. That can be simplified a little bit more. So x times x minus 5 and x plus 3, I think will work for that. So then when we set each of these factors to 0, x equals 0, x equals 5, and x equals -3. So those are our zeros as well. So you can find them by factoring, you can find them by graphing. There's several different ways that we can find our zeros. Now, multiplicity describes how many times a zero appears in a factor, okay? The number of times it corresponds to the linear function. So let's take this first one and let's factor it out. Oops, I've lost my pen. Let's factor this out. If we take an x out of that, then we're left with x squared minus 6x plus 9. Okay, so that's our factored form. We can simplify that further though. X times x minus 3 squared. So here we have x equals 0. We also have x equals 3. But because there's two of those, that one has a multiplicity of 2. Okay, this one has a multiplicity of 1. X equals 3 has a multiplicity of 2. So we would write that here, x equals 3, multiplicity of 2, and then x equals 0, multiplicity of 1. Okay, so because of this squared, that one has a multiplicity of 2. This one isn't squared or anything, so it just has a multiplicity of 1. So what that means, that kind of tells us what happens on the graph. If you have a multiplicity that is odd, then that means that it crosses the x-axis at that 0. If you have a multiplicity that's even, then the graph is going to bounce at that 0. Okay, so this is a cross, so it crosses there. This would be a bounce, so it bounces there. It starts, it goes down, and it goes back up. Or it could do it on the other side too. Okay, so these are cross, these are bounce. And so we can get some additional information about what our graph looks like by understanding our multiplicities and our factoring. So let's work through this next one. So we're supposed to graph this. Now we could graph it in our graphing calculator, but let's try to figure out kind of what this graph is going to look like without graphing it first. So if I factor out an x, then I have x squared minus 6x plus 9. I can factor that further, get x minus 3 squared. I think that's the same one as we just did. Yep. Okay. So at 0, that is an odd. So it is going to cross the line at that 0. And then we have our x equals 3. So if we go to the 3, it's going to bounce there. So let's go and graph this in Desmos and see what it looks like. So if we type in our equation, x to the third minus 6x squared plus 9x. It's given us our equation there. And so what we see is that it's crossing right here at the first 0, at 0, 0, and then over here at our second 0 at 3, it's bouncing. It goes down, it hits the 3, and it bounces back up. And so now we can draw that in our graph. It crosses at this 0, goes up to about 4, I think, and bounces and goes right back up. That's an ugly graph, but that's kind of what it looks like. Okay? So what I want us to do is just try to kind of nail this in our head. So let's look at these examples. Here we're going to have a 0 of x equals negative 7, and that one is going to have a multiplicity of 2. This 0, 2x plus 1 equals 0, so that's going to be x equals, we bring the 1 over, we divide by 2, negative 1/2. That one's just going to have a multiplicity of 1. And then the other one, x equals 4, that one's going to have a multiplicity of 3. So our zeros are negative 7, negative 1/2, and 4, with a multiplicity of 2, 0, and 3. So because this multiplicity is even, it's going to bounce there. The next one, because the multiplicity is, oh, I'm sorry, not 0. There's never a multiplicity of 0. That should say 1. Multiplicity of 1. It is going to cross there because that's odd. And then down here, this one, 3, is odd. So it's also going to cross there. Okay? Let's try one more. Here we could factor out an x squared. We could even actually factor out a negative 2x squared. That's going to leave us with x squared minus 2x minus 8. So if we simplify that, that's going to have x minus 4 and x plus 2. So our first 0, that's going to be 0. This one will be 4, and that one will be negative 2. If we set all of those equal to 0, all of them should have a multiplicity of 1. None of those have any type of squares or exponents or anything like that. So they have a multiplicity of 1. So this, for all of them, because they have a multiplicity of 1, 1 is odd, they are going to cross. Okay. Number 8 asks us a polynomial function has a 0 at negative 6, multiplicity of 2, and 2, multiplicity of 1. Write a polynomial function in standard form that could represent this. So if it has a 0 at negative 6, I'm thinking that it's going to be something like x plus 6. That would give us a 0 at negative 6. It has to have a multiplicity of 2, so that means that has to be squared. And then 2 might be x minus 2. That has a multiplicity of 1, so that would be to the first power. Okay? So now we actually have to like multiply this out to get our function. So x plus 6 squared is going to be x squared plus 12x. I can do this in my head. You may actually need to write it out and see it, okay? X squared plus 6x plus 6x plus 36. So that gives us x squared plus 12x plus 36. Then we still have to multiply by this x times 2. So that's x to the third plus 12x squared plus 36x minus 2x squared minus 24x minus 72. We have to simplify that. Okay, and that's what I got. That is a standard function polynomial that could have that, okay? So that's how you would do something like that. Come up with the pieces here and then kind of FOIL backwards. Go from there. So what I want you to do today, I know you do not have this page, but if you're able to print it and you want to print it from here, or I will link it in Google Classroom, you're more than welcome to print it. Or if not, you can just write it on your own paper, create your own little boxes, and then we'll just staple it to it when we turn them in. We're not going to do the whole thing, so you can finish up the rest of it at school later. So we are going to do numbers 1 through 8, okay? 1 through 8. So these are already factored for you, so these first two, so that makes it pretty easy. This one, your first 0 is 0, and then 1 and -5, multiplicity of 2, 4, and 1. So then you'll just have to tell me if it bounces or cross, okay? Remember, odd crosses, even bounces. If you have any trouble, let me know. Again, we're going through number 8, 7 and 8. You're going to have to write functions like you did right here. And then we'll stop and not finish the other parts. So I hope you'll have a great day.